Good evening, all of you. Welcome, you guys. Welcome, you all. I hope we are live. So, could you please confirm the audio and video? Am I audible to all of you? Tell me. Could you please confirm the audio, video? Is it fine to all of you? Tell me. Audio, video is clear to everybody. Could you please confirm about the audio, video is clear to everybody? Welcome, you guys. Welcome to the live sessions. Right, so we are coming to offline first time in New Delhi. So all of you get ready for 2023-2024 GATE ESE. So here you fellows are preparing seriously for 2024-2025. It's a golden opportunities. And these are the discounts we are offering for the students, and the 50% of discount for the already who has taken the plus subscriptions, and 50% discount the students who have taken the who has joined some other institutes, and 33% for the top 50 members. Means first 50 members we are offering the 33% discount, and whose rank is under less than 1000, those fellows will get 20% of discount. And this is the classroom environment and all. Have a look at here. The classroom environment is like this. And another new thing, we are starting exclusive batch. Exclusively we are selling one new course that is for only engineering, mathematics and the general aptitude for GATE and ESE. The students who want only these two subjects, engineering, mathematics and the general aptitude, so those fellows can able to plan this course. And here this goal is a GATE and ESE, EC and electrical goal, and you can get only the this exclusively for the this course. Only for this course you can get. In this course I am taking the engineering mathematics, and Saurabh sir will take the aptitude course. And so you can get this course is just 4999, and by using the code of B V REDDY you will get the another great discounts आपको मिलने वाला. And this last date for this, which is the 10th March. Right, so don't use it, don't waste, and try to utilize this opportunity as soon as possible. So as you might know, here we have recently started one batch. So this batch we have started for 2024-2025, and I am taking the EMFT. So you can find the top educators team. Have a look at the top educators team here. And these are the batches for the E batch for ECE, and this is for 2025 EC, and these are the main features of GATE and ESE, and this course is for GATE, ESE and CSC mains also. Right, and these are the features you can see. These are the features for the Unacademy Center, Iconic, Plus as well as a Light. Light means test series. Fine. Chalo, let's start our discussions. And last class how many problems we have completed? Tell me. Last class हमने 117 problems complete किया. All of you tell me. And previously we have completed the 117 problems. All of you tell me. Now let's continue the remaining problems. Now let's continue the remaining problems, all of you. Fine, chalo. And take the next problem, 118. Take the next problem, 118. The complete set of only logic gates designed as a universal gates. You tell me now here, which are the universal gates? What are the universal gates? You tell me. कौन सा option? Tell me. NAND gate and NOR gate is also called as universal gates. NAND and NOR called as universal gates, right? Next, and take the next problem. All the logic gates shown in the figure has a propagation delay of 20 nanoseconds, right? A is equal to C is given and B is equal to 1 before until T is equal to 0. At T is equal to 0, all the inputs are changed. Flipped means changed. Now they are asking to find and remain the same state. For T greater than 0, the output Z is equal to 1 for a duration of. All of you understood the problem? Yes, this is one very good problem. All of you listen here how we can solve it. Everybody. Now this is B. Now here I am calling this output, which I am calling this thing as a Y1, and this I am calling it as what? Y2. Now finally this is not C, this is Z. Okay. Now I want to draw this output Z. I want to draw. सबसे पहले A, C, B values, you see this thing here. All these values are what now here? Yes, before T is equal to 0, these values are zeros, isn't it? Right. Exactly at T is equal to 0, these values will becomes 1. Now this is A. All of you tell me. And this is C. Next, whatever the B, tell me now here. B value before T is equal to 0, which is 1, at T is equal to 0 onwards, which is 0. This is B. First of all, understood the problem, tell me. This is the data they has given, right, all of you? Now let us find the output of this NOT gate now here. This NOT gate has a delay. How much the delay, you tell me? How much this NOT gate has a delay? If we see this thing Y1, what is this Y1 is given as, tell me? Y1, which is nothing but what? Now complement of B. Yes, Y1 is nothing but B bar. So that means how the Y1 must be now here? How the Y1 must be? Y1 must be, yes, it should be inverted form we should have, now tell me. But because this gate, how much the delay this gate has, you tell me. This gate has a delay of 20 nanoseconds. So that means because of the delay, so how it will be the Y1, you tell me? Y1 will becomes like this. Isn't it, all of you tell me? Now at this location which is 0, at this location which is equal to 20, done. 20 nanoseconds delay. Now from this we'll get the output Y2. Y2 is what, you tell me? Y2 is the output of the NAND gate. So what are the inputs for here? A and Y1 are the inputs. Assume that this NAND gate does not have any delay. If this NOT gate does not have any delay, so tell me, if don't have any delay, what will happen? You tell me output now here. You see this thing here. Now up to 20, so this Y1 value 0. Now here this somewhere we have 20 now here. I can say up to here output is 0. Thereafter this A value 1 and Y1 is also 1 now. So we should get the output we need to get from 20 onwards. Output must be 1 we need to get. Yeah, 20 onwards output is 1. Yes, AND gate only. 20 onwards output is 1. But lekin, so this gate has some delay or not? So because of the delay, it will be delayed by, it is right shifted by 20. Yes or no? So that means output of this Y2, it should become like this. isn't it? Tell me now here. So this is 0 and here this is 20 and this is 40. Is it fine? Tell me all of you. Is it clear? Tell me. Now this is my y2. Next, now I need to get what now here? Z I need to get. Whatever the Z is given as what now here? XOR gate. As we know, when the output of XOR gate is 1, for equal inputs or unequal inputs? Unequal inputs output is 1. So this Y2 and C are the inputs. Now you see this thing here. At this location 0. Now you tell me now up to 0 Y2 value C value both are zeros. So we'll get the output is 0. Now you tell me now here in the interval from 0 to 40, if you see here, in the interval 0 to 40, you see this thing, this value how much you tell me? 1, and this value which is equal to 0, now tell me. So we'll get the output. So in this interval my output is what? In this interval my output is 1 will get. 1 will get. But this XOR gate has a delay or not? Tell me. XOR gate delay as a 20 nanoseconds. If I don't have any delay, so generally we should expect the output from where you tell me? Between from 20 to 40, we need to get the output is what? 20 to 40, we expect the output is 0. Yes, sorry, 1. Between 0 to 40, output will get it as a 0 to 40 will get 1. Yes or no? Tell me. यहाँ से यहाँ तक and यहाँ से यहाँ तक. Till in this interval will get the output now here. Provided if I don't have delay. But this gate has a delay or not? So that delay we need to add it now here. This 20 and this 20 we should add it. So finally क्या होगा? Tell me. So here where this will be? Will get this value output. ऐसा आएगा कि नहीं? Now this value will becomes what now? 20 and this value will becomes what? You tell me. 60. This value will become 60. This is my final output now. Yes, this is the output what now here? Without delay. Without delay. And this is the output with delay. So you tell me now here, how much duration my output is 1, you tell me. How much duration my output is 1. This is the 40 nanoseconds of duration. My output is 1. That's what they are asking in the problem. Tell me. How much duration they are saying the output is 1. So in this interval only my output is 1. From where to where? 20 to 40. 20 to 40. In this region my output is 1. So kitna duration here? 40 nanoseconds. All of you tell me. Done. Yes. Any doubts you tell me in this? Any queries you have? इसमें? Shall we move to the next problem? Next one. Take the next problem 120. Consider the logic circuit with the input test signal shown in the figure. All the gates in the figure shown have identical non-zero delay. Identical delay but non-zero. The test signal, yes, which was at logic low means logic 0, is switched to logic high and it is maintained at logic high. Means what they are saying is initially the test signal is there now. This is the signal, test signal they given initially, which is logic 0, and it become logic high, and it is maintain the logic high forever. It maintain the logic high forever. Now they are asking what will be the output. They are asking the output is a NAND gate output. Fine. So this is my test signal. Tell me all of you, first of all, this is the my test signal. Now let us call this output of this first NOT gate I am calling as A, and this I am calling it as B, this I am calling it as C, this output is Y. Now let us draw this thing here, all of you. First let us draw this A output, and how this output of A, tell me, which is a complement of test signal. So let us assume this, they are saying that all will have an identical delay. So let us consider the delay of each gate. I am assuming something, let us say TPD, we are assuming this thing as a 2 nanoseconds. Okay, all the logic gates have identical delay, let us say that is 2 nanoseconds. Now this is T is equal to 0 here. Fine. Now tell me now here, A is equal to what now? Complement of the test signal. That means, so here, because complement means how it should be now here. Basically we need to have like this. We need to have this A is like this. Yes or no, basically. But because of this there is a delay, what happens, you tell me? Because of the delay, this transition will be delayed by some time now. How much time it is delayed, you tell me? 2 nanoseconds. All of you tell me this thing here. So this is my A. So here, how much the time here, tell me? At this location, which is equal to 0, at this location, this is at 2 nanoseconds. Next, now let us see the B now here. B is nothing but what now here? Complement of A. B is nothing but complement of A. So complement of A means how we should have B, tell me now here. We need to have B. ऐसा होना पड़ेगा, B is like this. This is the B. This is the B provided if I don't have any delay. Yes or no? But because this NOT gate also have a delay na, so that's why this transition was postponed now, tell me. It is postponed by what I can say here, another 2, that means what now here? 4 nanoseconds. It was right shifted by 2 nanoseconds. And tell me what is C, tell me here. C is equal to what now? Complement of B. Complement of B means how we need to have, tell me. Complement of B means like this now here. We need to have like this. This is my C. If I say this is my 0 at this location, this is 0, and here this is 2, and this is 4, but it is delayed by another 2. Why? This NOT gate has a delay na, so that why it is right shifted by another 2 nanoseconds, I can say. Right, so that means here which is equal to 6. यहाँ तक clear ना बोलिए all of you. This is the C will get. Now let us see the Y. Y is the, what is the input for this Y, you tell me. Input for this Y is a test signal and C are the inputs. And assume that this NAND gate has no delay. Actually we have some 2 nanoseconds. First assume that it does not have any delay. If I don't have any delay, you see this thing here. Now in the region, in the interval of, you can see now from here to here, up to 0, this is 0 and this is 1. So we'll get the output will get as what, you tell me. आउटपुट हमको 1 मिलेगा ना, टेल मी 1 मिलेगा. This is up to 0. Thereafter you see this thing here from, you see this thing here 2 to 6, 2 to 6, this test signal is 1 and the C also 1, so we'll get the output is 0 होगा ना. Yes, now from where to where you tell me? This is from 0 to 6 and after 6 output is 1, 0, this is 6 and this is my final output. This is the output if I don't have any delay, but this will have some delay or not. Because of the delay, so what happens now here, this transition will be delayed by what now, 2 nanoseconds now here. So I can write it as, what you tell me now, the transition whatever is happened, this transition I can say this is from 2 nanoseconds and this will become 6 plus 2, 8 nanoseconds होगा ना, tell me. Now you tell me the final output कैसा होगा, you tell me. Final output how it is now here, tell me, you can see. So this is final output initially which is high and after that it is low, after that again high, you see. Now tell me कौन सा option satisfies, you see here. The pulses from where to where, high to low, low to high. Option D, check it all of you. Isn't it? बोलो यार, आया कि नहीं, सभी ने जल्दी बोल. कोई डाउट हुआ क्या, बोलिए. चलो next problem. Yeah, take this thing. This is also same the delay analysis. I think today we are getting all the delay analysis problems we have. Right. Now see the problem what they given here. This is x-axis. Now here at this instant they given this is input here. This input at initially 0, exactly t0 the input will becomes what now here, vi 1. Input is 1. Now you see this thing here. Now let us call this output of this first NOR gate, I am calling it as y1 and this is the final output. Now this is the input is given, now tell me for this thing. Now can you tell me now what is a y1, tell me. How the y1? Y1 is nothing but complement of the input, you see this is a NOR gate, now tell me. Complement means what now, this having some delay. How much the delay, you tell me here. They given this as a 10 nanoseconds delay and this will have a 20 nanoseconds delay, right? Now you tell me now here how we'll get the y1. The y1 which will get it as what, you tell me, initially which is equal to 0 and we need to get this as a complement, ऐसा आना पड़ेगा. All of you tell me now, basically this is the y1 provided if I don't have any delay of the G1 gate, but the G1 has some delay or not. How much the delay G1 has? 10 nanoseconds. That's why it is postponed by 10 nanoseconds now here. It was delayed by 10 nanoseconds. So that's why it will becomes what, you tell me now here. It will becomes what, you tell me, how it will be now here. At this it is delayed by 10 nanoseconds, right? Like this. At this instant this value, how much the time is t0 now. Now this time is what now here, it is t0 plus 10. Now this time is what? T naught plus 10. It is 0 continuously. Now you see this thing here, the input for this XOR gate. Input for the XOR gate is what? Y1 and V1. These two are the inputs, right? Now you see this thing, when the output of XOR gate is 1, for same inputs or different inputs. For the different inputs, output is 1. Yes or no? Now if you see carefully, up to T naught, this is 1, but this is what now? 0. So output क्या होना पड़ेगा? Output has to be a 1. Now tell me where? Up to T naught. And thereafter T naught to T naught plus 10. So T naught plus 10 means somewhere here na. Both values are 1, so output will become 0. Output will become 0. Right. Thereafter you tell me now this is 0 and this is 1. So output will becomes 1. Now this is my output. If you see the limits, you see this thing, this is what now? T naught, and this is T naught plus 10. If you observe carefully, this is the output when this XOR gate does not have any delay, but this XOR gate has a delay or not. How much the delay of this XOR gate, you tell me? How much the delay of this XOR gate, you tell me? It has a delay of how much? 20 nanoseconds. So the 20 will be added to here now. So if we add this 20, you tell me now here how the final output kaisa hoga, tell me. If we add this 20, so this all the limits we should add the 20 now, tell me. So then it will becomes what now here? That is T naught plus 20 means somewhere here, and the T naught plus 30, 20 plus 30 ऐसा होगा ना here. So this time is what now? T naught. This time is what now? T naught plus 10, right? ऐसा होगा. And this time is T naught plus 20, and this time is T naught plus 30. All of you tell me. Like this A बनेगा, isn't it? Now you see this thing here, कौन सा ऑप्शन आप ध्यान से आइडेंटिफाई करना पड़ेगा. Now they has called this as a T1, they has taken, sorry, T naught they has taken, this is a T1, this is a T2, and they has taken this as a T3 in the options you see. So can you identify the कौन सा option here, tell me? Can you identify this option now here? Output क्या होगा? You see this thing here, output which is equal to 1. Yes, up to here output is 1. In this interval output is 0. Again the output is 1. Tell me here कौन सा ऑप्शन satisfy होगा? ऑप्शन बी सही होगा ना? चेक करके बोलिए. They given T0, T1, T2, T3 form they given. Done all of you? So how many of you done this? सही किया? कितने लोग सही किया बोलिए? Done? चलो next problem. Yes, remaining problems are easy. So the delay problems are there now. These are only the some challenging problems. These are the some little challenging problems. Tell me now, which is the what they are asking? Which of the following is equivalent to AND OR logic? Here tell me the AND OR logic. So this is which is in case of two level AND OR logic is identically equal to two level NAND logic. Two level AND OR logic is equal to two level NAND logic. All of you tell me. is identical equal to what? 2 level and NAND logic. Yeah, so again delay problem only. Yes, tell me now here. Again delay problem. Yes, tell me here. Okay, first of all, let us get the expression here. What they given. Of course, this is not a delay, it is just a output only. Okay. And first of all, here what I will get now, this is a plus b whole bar. And again bar they given, so it will becomes a plus b. Right, so that means x is equal to what, you tell me? A plus b plus b. So that means x is equal to what now here? Simply a plus b. The a plus b, which is nothing but what? Simply R gate. Simply R gate. And they has given this input waveform they given. हमने कुछ ये सब प्रॉब्लम हमने डिस्कस किया ना here. They given the input waveform they given. Now I need to draw this output waveform for the corresponding input waveform. Now ध्यान से देखा तो here how it is input waveforms, you see carefully. The input waveforms E and B they given, and we need to see this as output waveforms. Yes, tell me now kaisa hoga, tell me. All of you listen carefully. Right. Now you tell me now here. This thing here. Now in this interval, you tell me now यहाँ से यहाँ तक this value 0, and this is what you tell me now 1 na. So we know XOR gate, if any one of the input is 1, output is 1. So this output here, up here it is 1. Next here this is 1, again 1 only now here. Next in this, now this is the 5 milliseconds, both are zeros. In this 5 millisecond, both values 0. So we'll get this as 0. Next, and from here this is 1. And so that means again up to, I can say up to here this is 1. Right. Yes, this is 1. In this interval also 1. And yahan tak this is up to here this is 1. Yes, like this. In this region, both inputs are 0, then it is 0. अगर आपने ध्यान से ऑब्जर्व किया तो you can see this thing here. This part, can you tell me how much this part, you tell me, which is equal to 5 nanoseconds. If you see carefully, this is milliseconds. 5 milliseconds. And how much this part, you tell me, this part which is equal to 15 or 10, you tell me. This is the 15 milliseconds, you tell me, all of you. And this part is again 5, and this part is again 15. Check it, all of you, tell me. This is 15 milli 5 and this is 15 milliseconds. Yes, अभी बोलिए आंसर क्या है, बोलिए. Now कौन सा ऑप्शन, tell me. So that means 15 milliseconds is 1, 5 milliseconds which is equal to 0. So कौन सा ऑप्शन, now tell me. ऑप्शन बी तो सही ना, check it. ऑप्शन बी सही, चेक करो. Yes or no? In this option D, you see this thing, they given this 10 milliseconds only na. It is not 10 na. 15 milliseconds is 1, you see. Here you can identify. Here you cannot see na. Why? Because some of the waveform is not given. यहाँ से देखो इधर. Okay. Next. Yeah. So this, I think so we have so many waveform problems today, completely waveform problems only. Right, tell me now here the output which is given as what? AB bar. That is a NAND gate. Tell me, when the output of the NAND gate is 1, if any one of the input is 0, output is 1. You see this thing from here to here, 0 is present, right? So output is 1. And you see this thing here, यहाँ से यहाँ तक 0 is there. So output will be 1. If any one of the input is 0, output will becomes 1. Isn't it? And then what else now here in this interval this is 1 and here also this is 1, so that's why output will become 0. Next, again in this interval again which is 1 here this is both inputs are 1 1 only, so then again will become 0. Isn't it? Can you tell me now कौन सा ऑप्शन होगा, चेक करके बोलिए. That is option D. Tell me. Isn't it? Done? Chalo. Fine. Next one. Yes, today I think so completely all the problems are based upon the delay analysis only. Yes. So you can see the waveform properly. ये waveform आपको दिख रहा कि नहीं ठीक से? एक बार देख लो इधर. Right. Now you tell me now here. So this is the input waveform. This is the input waveform is given and this is the output waveform V0 is given. Output waveform V0 is given. Now they are asking to find the duty cycle. You see this thing here. For this particular input waveform, yes, this is one waveform. They given this output waveform is given as like this. So from यहाँ से यहाँ तक this up to here T1 output is 1, and in this interval of T1 to T2 they given this output as what, you tell me? 0. Again from here this is again this output is 1. So this is one complete time period. Yes or no, tell me? This is one cycle, I can say. यहाँ से यहाँ तक this is one cycle. The same cycle is repeating. Now tell me, this is the time period. This is the time period. Now if you see carefully, now यहाँ से here in this interval, so you see this thing, my output is 1. This in this interval my output is 1, which we can call this as a T on period. In this interval my output is what, you see this thing here, this is my off, output is 0. Isn't it? And this is my total time period. Now you can see now here the duty cycle which is given as what? The duty cycle D which is given as on period by total time is called as a duty cycle. On by total is called as a duty cycle. Now so how much duration is on, you tell me? From यहाँ से यहाँ तक this much time is on, isn't it? Tell me, which is given as T1 time is on. If we see this thing, this is from here to here, they given this as a T2 is given now. So that means T1 by T2 is my duty cycle. Yes or no, tell me all of you. T1 by T2 is my duty cycle. Fine. Now let's see this thing, how we can get the T1 and T2s. we'll get these values of T1 and T2s, how we can get, right? So let's see this thing how we can get now here at these locations. Now this is a straight line, now tell me. So this is a straight line, you tell me now here. We can get the coordinates of this point, we can get it or not. Coordinates of this point, or what else we can do, we can use similar triangular properties. Similar triangular property. If you see carefully, this is a triangle, you see. This is one big triangle. This is one big triangle. If I call this thing as a B, and see, this is one big triangle, and there you can see one more small triangle also, you can see now. This is another small triangle, I can say. This is A, let us say D and E. These are similar triangles, you tell me. Similar triangles. Now what we can say now here, so similar triangular properties, what we can say now here, AB, that is base of the big triangle by base of the small triangle, and which is equal to what I can say, tell me now here. So this thing, so this dimension which is given as AC by what I can say now here, AE, by using a similar triangular property. So you see this thing, how much this AB value? AB value is a T2 and AD value is what you tell me, T1, which is equal to how much this AC? AC means from here to here na. यहाँ से यहाँ तक कितना distance, you tell me, length, you see this thing, how much voltage you see, which is nothing but what now, 2.2 minus 0.4, which is equal to, tell me now, 1.8 volts by AE. How much is AE value? That is 1.3. Tell me. Now this is the T2 by T1, but my duty cycle means what now, tell me. That is a T1 by T2, that means what we can say here, 13 by 18 I can say. Percentage means we can multiply with 100. Percentage means we'll multiply with the 100. So can you tell me how much the duty cycle will get? How much the duty cycle I will get, tell me. What's the answer? कितना आएगा? I think you will get the answer is 72 something you will get. Check it all of you. ये आया सभी को? Right. Next one. Tell me the next problem. The circuit shown in the figure is, what is the circuit, to tell me now here. Now can you tell me the output of F1? F1, which will get it as what now here? X bar plus Y whole bar. So which is given as what we can say, X into Y bar. Next, whatever the F2 you tell me, F2, so which is equal to X bar plus Y bar whole bar plus X plus Y for this whole bar. So that Y, what I can say, my F2, tell me. Yes, which is nothing but this is now XY plus X bar into Y bar. So this is nothing but what I can say now here, x, x nar, y nar, tell me. And what about the F3 value, tell me, which is equal to, that is x plus y bar whole bar, which is given as x bar into y. Have you ever seen this type of outputs, you tell me? Now we have got this as F1, which is equal to x into y bar. This is the expression we'll get for what, you tell me, in case of x greater than y, this expression, now tell me. And if we see this thing F2, which is given as x nor y, means this indication is what now, x is equal to y now. Next, F3 value, which is given as x bar into y, which is equal to x less than y, isn't it? So what I should call this type of circuit is this is nothing but comparator circuit or not, which is nothing but 1 bit comparator na, which is nothing but 1 bit comparator circuit, right? Next, take the next one. Assume that only x and y logic inputs are available and their complements x bar and y bar are not available. Okay, what is the minimum number of 2 input NAND gates required for the implementation of XOR? Tell me now here, XOR gate, how many NAND gates required? Tell me 4. ये तो हमको बड़ी बात जानता है ना. Tell me, we know very well this thing. Tell me, how many NAND gates required for Barfi के लिए कितना चाहिए? 4 required. Done. Next, the output of a 2-level AND logic network is F. What is the output when all the gates are replaced by NOR gate? What is the output when all the gates are replaced by what? NOT gates. Sorry, NOR gates से replace किया. Then क्या होगा, you tell me? They are saying that 2-level AND. That means level 1 we have a AND gate, level 2 we have OR gates. Now tell me क्या होगा if I replace it now here. Let us take some small example now here. And AND gate we have taken this as AB plus CD I have taken. Now you tell me क्या होगा. So this is level 1 we have a AND gate. Level 1 we have what? AND gate. So this is AB and CD. And level 2 we have what, tell me now here? OR gate. Level 2 we have OR gate we have. This is my F. Now what they did now here, basically this is the gate we have to implement, but he has replaced all the gates with the NOR gates से replace किया. Then क्या होगा, tell me now. If I redraw this one with the NOR gates, क्या होगा, you tell me. And we have redrawn this thing with the NOR gates. Now this is A, B, C, D, and this is like this. Now this is, now let us say this is my F1 and this is my F2. We need to get the relation between these two. Tell me what I'll get now here. Here this is what now, A plus B whole bar. This is C plus D whole bar. So what is this F2, you tell me? A plus B bar, okay, plus C plus D bar. For these two whole bar, now tell me. So from this, what I can say, this f2, what I'll get? This is a plus b into what now here? C plus d will come now. You see this thing here. This is my f2, and what is the f1? You tell me. This is ab plus cd. Tell me now here. Can you tell me what is the relationship between f1 and f2? f1 and f2 देख के आपको पता चलेगा relation between these two. The dual of f1 is f2 or not? How these two are related, you tell me now here. The dual of f1 is f2, isn't it? So option C. बोलिए. Done. Chalo, next one, tell me. For the logic circuit given below, what is a simplified Boolean expression? The minimized Boolean expression they are asking. Yeah, tell me now here. This is A here, and here we will get this as A plus B, and this is BC, and here this is A plus B into BC. And so the x is given as what, you tell me? A plus B into BC. So this x is equal to what we can say, this is A plus ABC plus BC. So what I will get, you tell me now here. A we have taken common. This is 1 plus BC plus BC. So what I will get, you tell me now here. This is A plus BC आएगा. So this is what you tell me, A plus BC. So कौन सा option tell me? Option B. Right. Next. Which are the following are universal gates? Which are the universal gates? NAND gate, NOR gates are the universal gates now. So 1 and 2 are universal gates. NAND gate, NOR gates are the universal gates. Next. In the NOR configuration, the minimum number of NOR gates required for this function. Now tell me now how many NOR gates required they are asking. This is x plus x y bar z. So if I have taken the x common here, what I will get? This is 1 plus y bar z now here. So this is 1 plus anything is a 1. So this expression हमको क्या मिला? You tell me now here. हमको x मिला ना. So you tell me now, do we require any other logic gates to implement this function? We don't require any NOR gates now here. The number of NOR gates are what? How many? Zeros. Yes, tell me next one. And which are the following are the universal gates? What are the universal gates? NAND gate, NOR gates are the universal gates. So option D. Next. Yeah, tell me now here the logic function they given output is given as AB plus BC plus AC. Now what is this expression? You tell me now here. The output expression which is given as what? They given AB plus what? BC plus AC. So इसका min terms बोलिए. All of you know this. Remember this min terms of this expression. You tell me what are those? 3, 5, 6, 7. 3, 5, 6, 7. So tell me what are the names for this thing here we have given. This is called as a self-dual expression. This is what? This is a self-dual expression. What else? What else names we have given? This is also called as a majority logic gate. Now tell me. This is also called as a majority logic expression. This is also called as a majority logic gate expression. And what else the other name for this, you tell me? Which is a carry of a full adder. This is a carry of a full adder. And what else the other expression, other thing you tell me? And this is nothing but, ये तो आपका फोन पे नंबर है कि नहीं बोलो? This is your phone pay number ना, सभी को क्या है कि नहीं? So then what's the option, tell me now here? The output of the XOR, no, the output of the majority gate, ये सही ना? And carry of a full adder, so the 2 and 4 are correct. All of you? Done. Next, the minimum number of NAND gates required for this function. Tell me, अभी just we did this expression, I think so. अगर हमने ये कॉमन लिया तो क्या आएगा? This is 1 plus what you tell me? B bar and B bar C. So what I'll get this thing, which is nothing but ये ना here. So what I should call this is, you tell me now here. What will call this is? And which is the, we do require anything? Nothing is required now. Next, tell me minimum number of gates required. So they are asking to use what gates are? NAND gates. How many NAND gates are required for the implementation of this function? Tell me now here. NAND gate implementation के लिए basically the expression must be in the SOP form. Is it is SOP form or not? Yes, it is SOP form only. So first we should implement. We can use a double complement method na. We use a double complement method, that is AB plus C bar. We using the double complement method. Tell me now here. So that means F is equal to, so this is AB bar into what we can say now, C whole bar, isn't it? Now tell me what I can do here. I can, for AB implementation case, we required one NAND gate. So this is my AB. इधर मुझे आउटपुट मिलेगा. So this output here, this given C here, and these two are I am passing to here. This is another NAND gate मैंने pass किया like this. Now you tell me now what I will get this expression here. इधर हमको AB bar मिलेगा. So then what I will get now here, it is AB bar into C whole bar. That is the expression. Now tell me how many NAND gates required here in this case? 1 and 2. So 2 NAND gates required. Done. Next, see the next one. The match the list 1 with list 2 and select the correct answer using the codes given below. Yes. Tell me now here. Let us simplify the given expressions now here. So what we can do, y into y is y plus what now, this is yz. So which is nothing but y only na. So that means इसके लिए 2 is option. Next here in this case you tell me now here y. So it will be equal to mingle property. This is a y plus z. So what's the option, tell me for this thing is third one is a answer matching. And what is this thing here? So this is x plus y. So here SOP form we can write, but the options POS form में दिया ना. So what we can write now, this is y plus z into y bar plus z bar. So this means this is a 4. Here if we apply the mingle property, so इधर क्या होगा? This is x plus y into what now here? X plus z. Now you tell me the कौन सा option here? So this value which is 1. 2, 3, 4, 1. 2, 3, 4, 1. Option C. 2, 3, 4, 1. Option C. Next. Now you tell me the next one. The Boolean expression of the shaded part. You see how many shaded parts are there. This is one shaded part. I can say this is the second part, and this I am calling as third part. In the part 1 you see this thing what we have. In part 1 what we have? A is there, B is there, but no C. And second part what we have, it is second part what we have? No A and no B and only C is present. And third part what we have, it is A is present, B is present, C also. Right. Now if it is possible, try to minimize this thing. And is it possible to minimize this thing or not? You see. Now can I combine these two here? Mingle property. Sorry. If I have taken this as a AB common, here this as AB plus A bar B bar C आएगा. So the option is D. Next. Yeah, tell me now here. So they given the 4 variable XOR gate. 4 variable XOR gate का min terms आपको remembered or not? I have given one trick also to remember. So 3 variable is 1, 2, 4, 7. And what is a 4 variable case? What we should do? We need to subtract with what you tell me. Remember the trick what we have discussed. You need to subtract with the 15 से subtract करना पड़ेगा. 15 minus 7 will get 8. 15 minus 4 11. 15 minus 2 13 and 15 minus 1 14. These are the min terms of the 4 variable XOR gates. If these are the min terms, can you tell me the max terms? Can you tell me the max terms? Remaining are the max terms होगा ना? Tell me the max terms what will get? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what's the option? Tell me. So this is 1 and 3 are correct. Means option D. Isn't it? Next. Now take this thing here. They are asking which are the following expressions are what? Functionally complete. Functionally complete, the trick आपको पता ही ना बोलिए. We should get it as a NAND gate, NOR gate, or AND gate plus NOT gate. NOT gate plus OR gate we need to get. Let's try this thing here. Functionally complete or not. Take the first expression. F is given as. Now in these two I can take this xy bar common. Xy bar common plus what now here? This is y bar z. Yes. Now you tell me, is it possible to get this NOT operation here? To get the NOT, what I should do? Tell me. X value 1, y, z value 0. Tell me what I will get. You tell me. हमको y bar मिलेगा कि नहीं? will get the not operation? Tell me. Agar not आया, then what I should do? Tell me. I can do it as what now here? So this is x comma y bar comma, and what I am doing, z I am placing it as 1. So इधर हमको not get मिला, right? So then what I will get now, this is xy will come now here. Xy means what we can say, this we got it as a AND gate. You tell me now, here we have a not plus AND, that means we have a NAND we got. So from this, can I say this is a functionally complete? So we can call this as a functionally complete. Right. Now coming to the G expression, now here see what happened to G expression here. G of x comma y comma z, if I minimize this thing, if we have taken this as a y bar z, we have taken common, this is 1 hoga na, right? Thereafter you see this thing, what we are left out, plus xy. If I take again x y will come na, इससे हमको we don't get the not gate. You tell me, it is not possible to get the not na, not possible here. Not gate is not, we don't get the not gate here. यहाँ से not gate नहीं मिलेगा, isn't it? So this is not a functionally complete, not functionally complete, not functionally complete. So what we can say, only F is functionally complete. Only F is functionally complete and the G is not functionally complete. Yeah, tell me the next one. Consider the Boolean operator is given as like this. See the Boolean operator, what they given? So they given this as a x star x slash given. Not 0, which is given as a x slash 1, which is given as what? Tell me, x bar. So by this thing, can you tell me now here what is the nature of this gate? To tell me. So this is nothing but XOR gate, I can say. Tell me. From this given data, we can say this is the XOR gate. All of you tell me. All of you tell me. So that means what we can say, this x slash y, which is nothing but what we can say, x bar y plus x into y bar. Yes or no? Tell me. So in which cases we'll get this type of operation? Tell me. Which is equal to 1. X slash x is equal to 0. All these properties, this is for which gate we have? These properties will have the XOR gate now. So that's why XOR. So कौन सा option? Tell me now here. Option A. All of you tell me this thing. Done. Yes. Fine. Okay. Chalo, here that's for today's class, and tomorrow we'll meet the same timing and we'll discuss the remaining problems. Tomorrow we'll discuss the remaining problems. Fine, all of you. Let's meet in the next class. Okay then, see you. Bye bye. Good night.